Resistors in series. A resistor is a material which offers resistance to the flow of current. Shown here are several types of resistors. Generally, in an electric circuit, a zigzag line represents a fixed resistor. Two thick dots at the ends represent brass terminals. In an electric circuit, resistors can be connected in series or in parallel. Resistors in series. Resistors are said to be connected in series if they are connected one after the other in the form of a continuous chain as shown here. Let us now calculate the effective resistance of the circuit. Consider three resistors R1, R2 and R3 connected to a battery through an ammeter. Observe the multimeter reading when it is used to measure potential difference across R1, R2 and R3. Now observe the multimeter reading when it is used as an ammeter. What do you observe? The current flowing through R1, R2 and R3 is the same, and that the potential drop V1, V2 and V3 across R1, R2 and R3 is different. Let V1, V2 and V3 be the potential drop across R1, R2 and R3 respectively. Under ideal conditions, potential drop across the resistors is equal to the sum of the individual drop in potentials. That is, V is equal to V1 plus V2 plus V3, where V is the total potential drop. Let us now calculate the effective resistance of the circuit using Ohm's law. Mathematical representation of Ohm's law is R is equal to V by I. In a series circuit, the potential drop across each resistor varies. Hence, we calculate the potential drop V1, V2 and V3 across the resistors R1, R2 and R3 respectively. The total potential V is equal to V1 plus V2 plus V3, but V is equal to IR. IR is equal to IR1 plus IR2 plus IR3. R is equal to R1 plus R2 plus R3. Therefore, the effective resistance of the circuit is equal to the sum of the resistances of the individual resistors in the circuit. Potential divider. Resistors connected in series can be used as a potential divider or a voltage divider. Let us consider two resistors connected in series across a battery of negligible internal resistance as shown here. Such an arrangement is called a voltage divider and is used in most of the electronic circuits. For the normal working of a transistor, as an amplifier or as an oscillator, we may require a voltage less than the voltage of the battery in the circuit. In such situations, we make use of this voltage divider circuit. Let us understand how the voltage is divided across the circuit with the help of mathematical equations. The current flowing through the circuit is equal to I is equal to V by R1 plus R2. The potential difference across the resistance R1 is V1 and that across R2 is V2. V1 is equal to IR1, that is equal to V by R1 plus R2 into R1. V1 is equal to IR1, that is equal to V by R1 plus R2 into R1. Equation 1. V2 is equal to IR2, that is equal to V by R1 plus R2 into R2. Equation 2. V1 by V2 is equal to IR1 by IR2, that is equal to R1 by R2. Equation 3. The equation 3 shows that the potential difference across a resistance is directly proportional to the resistance. That is, If R2 is small compared to R1, then the potential difference across R2 will be small.